Over.
No.
Next. Here. Point number 2. Okay. See. Snell's law of refraction. See, this is normal. A light ray is coming from one medium and goes to the medium 2. So when light ray enters from medium 1, goes to the medium 2. Okay? Now this is the wavelength of light. Right? What I wanted to do for a given wavelength, for a given wavelength of light. Okay? And for a given pair of media, for a given wavelength of light and for a given pair of media. Okay? Ratio of sin I to sin R. Ratio of sin I to sin R is constant.
So for a given wavelength of light,
For a given wavelength of light and for a given pair of media. This is a pair of media. Ratio of sin I to sin R is constant. Sin I by sin R is constant. So what is this constant here? Constant is refractive index. What is this constant? Refractive index of, okay, now refractive index of medium 2 with respect to medium 1 with respect to medium 1. So what is that? Sin I by sin R. Refractive index of medium 2 with respect to medium 1. Okay? Actually, what is meant by refractive index? See, when a light ray enters from air, light ray enters from air into a medium. When light ray enters from air into medium, this is air, this is medium. This is I, this is R. So when light ray enters from air into medium, this is called it is refractive index of medium with respect to air. So whenever light is coming from air into medium, it is called refractive index of medium with respect to air. It is denoted by symbol μMa. The refracted rays in medium, incident rays in air. Okay, refractive index of medium with respect to air. అర్థమైందా? It is also known as absolute refractive index of medium. What is meant by absolute refractive index of medium? Refractive index of medium with respect to air is called absolute refractive index of medium. Okay. Suppose, for example, is also given by mu m. We need not write even a here. Actually, air should be there. Here, need not to write. Even nothing is there means here is air. Okay. For example, rays coming from air into water. What this is called? Refractive index of water with respect to air. Or refractive index of water. This is ray is coming from air into glass. Ray is coming from air into glass. అంటే refractive index of
glass.
glass with respect to air. దీన్ని సింపుల్ గా ఏం రాయొచ్చు, మ్యూ గ్లాస్ అని కూడా రాయొచ్చు. అర్థమైందా? Okay. Suppose this is the normal. This is medium 1, medium, sorry. Frame వస్తుంది refractive index of medium with respect to air. This is velocity of light in air by velocity of light in medium. Suppose refractive index of water with respect to air. Velocity of light in air by velocity of light in water. Refractive index of glass with respect to air. VA by V glass. Suppose refractive index of suppose if this is medium 1, medium 2, light rays coming from medium 1 and goes to the medium 2. Okay, this is angle of incidence, angle of refraction. So when light enters from medium 1 into medium 2, ఏమవుతుంది, refractive index of medium 2 with respect to medium 1. కదా, దీని ఏం రాస్తావు, velocity of light in medium 1 by velocity of light in medium 2. కదా, V1 by V2 into VA by VA. VA by V2 into V1 by VA. VA by V2 divided VA by V2 in the mu2. ఇది ఏంది mu1. The refractive index of medium 2 with respect to medium 1 is mu2 by mu1. So it's like last number sin A by
Sin.
Done, sir.
Sin A by sin R అంటే mu2 1 క్రాస్ మల్టిప్లై చేస్తే ఎంత చేయొచ్చు mu1 sin A mu2
Sin R.
sir. That's fifth point. mu2 1 is equal to v1 by v2. v2 by what is the v2 by v1?
mu2.
mu
One by
v1 అంటే mu2 1
one
v2
by
by v1 అంటే mu1 2 ఇట్లా రివర్స్ mu2 1 అంటే v1 by v2 v2 by v1 అంటే mu1 2
okay.
అంటే ఇది mu2 1 equal to 1 by mu1 2 అంటే refractive index of glass with respect to water అంటే 1 by refractive index of water with respect to glass.
Yes, yes, sir.
Sir,
Ah,
that relation is true for all media.
ఇది
That relation, sir, mu of glass and water is equal to 1 by water and glass, right?
ah,
It is true for all media.
ah. ఇది జనరల్ ఫార్ములా ఇది జనరల్ నువ్వు గ్లాస్ వాటర్
Yes.
పెట్టుకొని ఇష్టం జనరల్ గ్లాస్ వాటర్ అందరికి తెలుసు కదా అని పెట్టి అంతే
Done.
when light ray enters from medium 1 into medium 2. Wavelength, velocity, wavelength, velocity changes, but frequency does not change. V1 ఇక్కడ V2, lambda 1 ఇక్కడ lambda 2. Okay. So what is the frequency? Ikkada frequency, ikkada frequency. Frequency in medium 1 is frequency and V by lambda. So, therefore V1 by V2 equal to lambda 1 by lambda. ఎంతవరకు మీ క్లాసు 11:45 to
12:30, sir.
12.
30, sir.
మన టైమ్స్ వేరు కదా
Yes, sir.
Yes,
Only
sir.
45 minutes class, sir. It is.
అదే. Next. Frequency same. Frequency does not change. Okay. Next. Optical path. It is the distance traveled in air. It is the distance traveled in air during the time it traveled in a medium. It traveled in a medium. Sure. You take, this is the medium. Okay? Thickness of the medium is T. Okay? Light enters through a medium of refractive index mu. So when a light ray passing through a medium, when light ray passing through a medium, thickness of the medium is T. What is the time taken? Time equal to distance by velocity. What is the distance? T. What is the velocity in the medium? Vm. Huh? What is the refractive index of the medium? Velocity of light in air by velocity of light in medium. So velocity of light in medium is c by mu l. Correct? Now you substitute time E by Vm into C by Vm. Vm అంటే C by mu m. అంటే mu m into T by C. Is that right? So in this time,
So your board is blurred, sir.
Yes, sir.
in traveled in air. In this time, what is the distance traveled in air? The distance traveled in air and this is called distance traveled in air is velocity of light in air into time. C. What is the time? Mu m into T by C. So XA equal to mu m into T. Okay? This is called optical path. This time
Once can you read that statement which you wrote under the diagram?
అదే
It's under the diagram which you draw. Yeah, that was.
in this time distance traveled in air. This is a time, no? This is a time taken by the light to travel in this medium. So in this time, what is the distance traveled in air?
Okay, sir.
The distance is velocity of light in air into time. Velocity of light in air, say c. Time is that. Substitute it. C cancel.
Yes, sir.
Okay, no?
Yes. Yes, sir.
Point number 7.
7.
8, sir.
Hello. Number of waves in a medium of thickness of thickness. Suppose this is the medium. Okay. In this, light is traveling. This is the wave. This is one wave, second wave, third wave, fourth wave, and so on. Wavelength in the medium is lambda m. Thickness is T. Okay. So, what will be the number of waves? Thickness into n number of waves into lambda n. N is the number of waves. You know, mu n equal to wavelength in air by wavelength in medium. Like velocity of light in air by velocity of light in medium. Okay. So what is the lambda m? Lambda a by mu n.
Here, mu m requires what?
T equals to n into lambda m ante idi. Lambda a, this is wavelength of light in air by mu n. Okay. The one entered. Some wavelength of light in air enters into a glass of refractive index glass with 3/2. Thickness of the glass is 3rd. Number of waves are 3rd. So number of waves equal to mu m into T by lambda a. Okay. ఇది ఇవాళకి మీ లెసన్. ఓకేనా? ఏం చేస్తారు? ఎక్సర్సైజ్ 2 ఉంది కదా, స్టార్ట్ చేయండి. ఎక్సర్సైజ్ 2.
Yes, sir.
నేను చెప్పిన ఏవైతుంటాయో ఆ కాన్సెప్ట్ పక్కన పెట్టుకొని చేయండి.
Okay, sir.
Okay, sir.
Okay, yeah, Nadia?
Okay, sir.
Thank you.